Okay, can you guys hear me all right now?
Yep. Seems like they do.
Okay, sorry you guys. I was just talking about what a great job the video crew was doing on the lighting. This is our 51st live stream. So if you go to our podcast, search for T.REX Talk on your podcast app, there are 50 shows that have actual audio that you can download and listen to while you wait for us to get the audio fixed. Later this evening, there will be 51 shows for you to listen to. And we also hit 1 million subscribers on YouTube last week. So thank you so much for that. Now, in this particular show, this week we're going to be talking about 3D printing. And there's a couple of reasons for that. One of them is that we have been running out of cool stuff to talk about, and 3D printing definitely qualifies. But the other is there's actually been some interesting developments when it comes to 3D printing news from a gun and legal perspective. So last week, and this is so hard to read about, partly because I'm not a lawyer, but also because I am a regular person with regular reading comprehension skills. But the Ninth Circuit lifted some restrictions on the exporting or publishing or sharing of 3D gun files. And the reason this is so hard for me to read and properly understand is because they speak somewhat interchangeably about 3D gun files, 3D gun plans, 3D gun specs, 3D gun blueprints, ghost gun things. And it's also a very circuitous legal thing because if you read one side, they're like, a terrifying Trump-era law that would have made ghost guns available everywhere was stopped by a courageous federal judge, but recently has been overturned by scandalously traitorous federal judges. Usually there's not quite as much editorializing, but that's essentially what happened, minus the editorializing. In the Trump era, a bunch of firearm export stuff, a lot of ITAR stuff actually got moved from the State Department over to the Commerce Department. That included files, blueprints, specs, machine code for firearm parts. And that is something that was, there was a restriction against that. There was a stay on that, and that has been lifted. So if you've been hanging out on the internet and you've seen 3D gun files posted on various places that host 3D files, that is the reason. There was a legal hold on those things. That legal hold is now gone. Of course, it's being appealed. But for now, you can actually download a whole bunch of 3D files of various firearm parts that can be 3D printed on different types of 3D printers. Now, if you understand how the internet works, you realize that nothing has actually changed. You've been able to get those files without very much difficulty whatsoever for the entirety of those files' existence. But now they're a little bit easier to get for people that don't understand quite how the internet works because they're on more public places. So let's talk about that a little bit. There's a couple of reasons why the discussion of ghost guns is so problematic. It's very focused on by the media right now because it is a terrifying boogeyman that they can bring up in an era of wanting to pass gun control legislation, but at a time when Americans are obviously not wanting gun control legislation, they are in fact wanting guns. If you look at the gun sales for the year 2021, they are going to, if manufacturing can keep up, they are going to easily trump the gun sales of the year 2020, which was a record at that time. So we're going to see that Joe Biden is a much better gun salesman than even Barack Obama was. The only question as to whether or not we can set the records for most gun sales of all time, pretty much just going to be related to supply. The demand is certainly there. Do you want to switch over to my monitor, Charles, while we do some stuff here? So one of the things that we're talking about today is an aspect of this discussion of ghost guns is entirely related to the fact that there's a political faction that wants gun control, and they're pushing the idea that Americans want more gun control, more gun restrictions, more limitations on what can be privately owned by folks. But at the exact same time, American citizens actually want more firearms, and we're getting we're getting a lot of more pro-gun legislation. We're getting stuff like constitutional carry in more states. We're getting permitless carry in more states. We're getting more gun. Oh, this is trippy, guys. If you're watching YouTube, you're seeing me watching YouTube while you watch YouTube.
I forgot to click over there when you.
Okay.
So sorry about that.
Here's some 3D files. No, it's perfectly fine because what they are seeing is what I am seeing that they are seeing. Here are some 3D files that we're going to be working on today, and then here are some 3D programs that we actually use to 3D print files on the 3D printers. And as soon as the camera comes back up, we're actually going to talk about how the 3D printers work. But so the media has really focused on ghost guns as this extra terrifying thing because Americans are not afraid enough of regular guns. And so one of the things that we are talking about as we discuss this isn't just mere gun control, but it is information control. Because when the media or the Democrats or any of us talk about restricting the flow of information so that a 3D file like this, so this right here is a 3D file, it's a little piece of Picatinny rail. It is a rail adapter that goes from this type of adapting mechanism to this type of adapting mechanism. That's all that this is. It's not a firearm part as far as function goes, but this is the kind of thing that theoretically could be banned because it is firearm related. But all that it is points and polygons, or it could be a 2D blueprint written on a piece of paper. Like, at what level are you able to control this information? So there's a philosophical aspect to this argument as well as the legal aspect to the argument. And then, of course, there's the practical side as well. The fact of the matter is, as I mentioned before, even though there's been some significant crackdown on the sharing of 3D files such as this, if you know how to find them on the internet, you have always been able to find them on the internet. They have always been there, and it has not inconvenienced anybody to have them not be on the front page of Google. And let me hop over here to another file that is kind of handy. This is a file that you might recognize what it is. I'm not going to say what it is. It's just a piece of plastic when we print it out, and that's all it is. It's just a piece of plastic. But people have been able to find and print this part regardless of what the State Department or the Commerce Department has been saying, and that's been a very interesting thing. The way that the internet works is you can't stop the signal. So there's a video about what is actually happening at this Ninth Circuit court decision. It's been put out by Fudbusters. I'll link to it in the description after I finish doing the live so that you guys can go and check that out, because he is a lawyer and he is much better at explaining that legal side of things. Now, from the technical side of things, you all know roughly how 3D printers work. And as soon as I get my camera back up, I'll be able to show you exactly what the 3D printer looks like in all the different parts. But this is the software that feeds the 3D printer the instructions that it needs. So right here, you build yourself your file in a design package of your choice, but ideally you should not use the one that I have chosen. You should use Fusion 360. And we'll talk a little bit more about that later. And so what you're going to do is you're going to take the 3D file that you have created, or the blueprints. Actually, you know what? I have to talk about this. So from a legal standpoint, the fact that the government cannot decide exactly how it wants to talk about blueprints, files, machine language, stuff like that is very interesting, because essentially what is happening here is a bunch of arbitrary nonsense. So a 3D file, like the one that was just on the screen, is too easy to print or mill on a CNC machine. And so that kind of thing is not allowed to be shared. But 2D blueprints, that's still okay. And the only reason that it's still okay is that's harder to do. But the fact is, what that is doing, if that is the tack that the Commerce Department or the State Department or the legislature or the Supreme Court takes, that's very problematic, because basically what you're saying is the best way to communicate engineering data has to be limited for certain types of engineering data just to make it harder and for no other reason. It's like hieroglyphics. It's like saying, oh, you can use English, a very commonly understood language that's capable of communicating technical data in great detail, to talk about everything, but not when you talk about guns. When you talk about guns, you have to write cuneiform tablets out of clay. When you pass each other gun information in an engineering standpoint, you have to do it in the oldest way possible, not using the 3D files or the machine code that is actually useful. You have to do all the converting yourself just to create an arbitrary speed bump for people that want to do anything with gun stuff. And this is bad. This is bad stuff because it's a slippery slope. And a lot of people will talk about the fact that, oh, the slippery slope argument's a bad argument. But it is an issue when you take a bad principle. Like one of the issues with gun control in the first place is this idea that certain items are just illegal to possess. So instead of making the crime doing something bad with that item, it's mere possession of that item that is in fact the crime. This is a very problematic thing from a moral standpoint, from a philosophical standpoint, from a legal standpoint, but even from a practical standpoint, this is dumb. If it is a crime to own something that is really, really easy to make, and it is becoming increasingly easy to make all of the stuff that you're not supposed to own, that's a major enforcement problem. And Prohibition in the 1920s is a great example of this, because alcohol is actually really, really easy to make. In fact, if you're dealing with grape juice, you find that alcohol is actually easier to make than non-alcoholic grape juice. And so enforcement of the Volstead Act was almost impossible, and obviously the authorities failed to control alcohol whatsoever by every metric. And now we're coming to kind of a similar thing where people are wanting to control not just the physical objects that are classified as firearms, but also the tools and information necessary to understand manufacture firearms. That needs to be controlled as well. And there's just no way to control that. And so they're going down this terrible rabbit hole that is a slippery slope and is going to be extremely, extremely difficult to unwind and actually get our freedoms back. Because once it's okay to take away people's right to share information regarding firearms, then you have a precedent to take away people's right to share other information as well. So in the great desire to infringe upon people's Second Amendment rights, you're going to take away people's First Amendment rights. And there's a lot of examples for this. I understand that as technology changes, it becomes harder and harder for lawmakers to actually use old precedent to figure things out properly. And sometimes they make terrible mistakes. Like when email was new, email was talked about as if it was the same as snail mail, the same with old mail. And one of the problems that people had as they legislated this was they said, okay, well, the way that mail works is that if you don't collect your mail for 30 days, then we consider it abandoned. If you leave it at the post office for 30 days, it's now abandoned and we can look at it without a warrant. And email is basically the same way. If you leave your mail on the server for 30 days, then we consider it abandoned and we can look at it without a warrant. But we do email differently than we do regular mail. That's not a great metaphor, because in the early days, mail servers were tiny and you would download the mail to your computer, but nowadays, all of your mail lives in the cloud. You look at it on a device, and it's just a terrible way of doing things. And what has happened is the way that we interpreted some of these files, file sharing, and the way we interpreted mail at a legal sense undermined the Fourth Amendment tremendously. And now the Fourth Amendment is way less important, and so new laws are going to be made without taking the Fourth Amendment seriously because of how incredibly undermined it has been, and that is the slippery slope thing. So as we talk about people wanting to infringe upon our Second Amendment by infringing upon First Amendment stuff, it's really important that we actually get down to some of these root levels and not just fight on the surface level when it comes to stuff like really, really basic application of firearm law, but we actually get down into the meat of some of these arguments. So let's talk about CNC machines. So right over here on, the monitor is kind of turned around, but on whichever it looks like to you is the Ender 3 Pro, and this is a filament printer. And then over here, I have the Elgu Mars Pro. Thanks for giving them such good names, guys. And this is a resin printer. So I'll talk about these in a couple of different ways because they do different things. So the way that the Ender 3 works, I apologize if you already know what 3D printers are and how they work and stuff like that, but I'm going to blitz through this for the guys that don't know that. Over here we have a hot end that heats up the filament into not quite a liquid and actually takes the filament off of a spool that usually hangs up here, pulls that down through the bottom, and then down here it actually begins to print layers of molten plastic onto the bed, just one layer at a time, and then the next layer, and then the next layer. And gradually it builds up an object that has thickness and substance to it. And the bigger the object, the larger volume of plastic you need to print, the longer it takes. But you can make a three-dimensional object. Let's see if we can get the focus to work. I feel like a different YouTuber. I feel like AVE right now, explaining how this 3D printer works and telling the camera to focus. So this right here is that Picatinny rail section that was on my computer earlier, and it now is in 3 dimensions. It is real, actual plastic. I can do stuff with it. And I can print out other stuff on here. Some of you may have seen these little, these keys here were printed out to adapt the TLR7 weapon light so that it can go onto the Glock 48 MOS. So having the ability to print plastic objects really simply and easily is a tremendous value for T.REX because we use it for prototyping, but it has a lot of other values too. People saying the filament is on backwards. Yes, sorry about that. I actually left the filament roll. We took it off of here and it's attached to the shelf where this normally lives, and I couldn't be bothered to bring it. Just kind of imagine it, you know, doing its thing. There's a bunch of different filaments you can use. This is ABS, which is hard to print with. You actually want to have an enclosure for that because it wants to warp as it cools. If you allow the molten plastic to go down onto this heated bed and then cool in an inconsistent way, then you will probably get shrinkage and warping that's not great. I actually feel even more like AVE now. Gentlemen, down here, the hot end gets heated by the electricity and comes oozing out in a metaphor that cannot be used on this particular family show. Keep your stick on the ice. So what we tend to make with these things are prototypes for T.REX. And some of my best prototypes I cannot show you because they're for products that are not yet out. But this is kind of an interesting one. And you can take this idea and steal it and run with it because I haven't had time to work on it much. But this is a hand stop. Focus, you camera. This is a hand stop for a probably some kind of semi-legal rifle. You could put it on a legal rifle, of course. But one cool thing about it is it's got a little tiny cutout in here, and you can take one of these little keychainy flashlights and pop it inside there. So now on your hand stop, you have a little tiny task light that you can use for stuff, like making sure you don't step on Legos, which is the main thing that I want in a weapon-mounted task light. When I'm doing CQB, there's always Legos on the floor. Just, that's how it always plays out. So yeah, it's a 3D printed part that has a cutout that accepts the little thingy. And then there's a ton of different flashlights that you can get. You can even get the IR spectrum flashlights and use this with night vision. So really simple shape, really interesting to just print it out, test it, see if it works, see if it needs to be a different shape. This is probably a little snug on that flashlight. But on the other hand, you don't really want it popping out, so maybe that's good. So the ability to do this rapid prototyping where you print something out and you immediately test it, you immediately get feedback, you can immediately print out version 2 and start testing that is fantastic. When we were doing a certain project, we were doing a couple of revisions a day on a particular part, and that is pretty phenomenal stuff. So I think we should probably actually put some of these files up, Charles, so people can experiment with some of these things themselves. But this printer right here, the Ender 3 Pro, is $236 on Amazon right now. So it's pretty easy to get into. The filament tends to be different prices. There's PLA, which generally is the cheapest. There's PLA Plus, which is stronger, but still easy to print with. There's PETG, which is stronger and easier to print with. There's ABS, which is stronger and not easy to print with anymore. Then there's nylon, which is not easy to print with in my experience. And then you need a piece of software called Cura, which is open source. And if you want to switch over to the computer feed there, Charles, here is our random 3D object here that we want to create in plastic. And we're going to slice it into the different slices that you might want to see. And it takes a little while because I think I have a few too many settings turned on. Now this is actually potentially a kind of a tricky thing to print. Let's check the preview here. One of the reasons that this might be tricky to print is if we print it at an angle like this, we should really have something holding it up on this side, maybe, probably. You can turn that on. You can turn on supports and render, or rather reslice it, re-export it. But what you see here, if we zoom in, is you see the layers that are going to get printed in order to build this object up from the bottom to the top. And there's a ton of different settings, most of which are automatically selected because I actually, in preparation, I made sure that I had my actual 3D printer selected and all the settings that it likes. And then I selected the black PLA Plus that I bought from eSun. So I should get all of the settings over here basically correct, and then I'm going to tinker with these settings until I get something that prints properly, even though at first it'll probably take you a while to figure out some of the things. And you might want to print easier stuff than these functional things that are a little bit trickier. So there's a whole bunch of things to learn in here, and there's a bunch of ways to get started. I would recommend that you look into Control Pew, which is a group of folks. I mean, it's probably one guy, but it's also a group of folks that are creating materials, and there's a great starting guide over there. So yeah, so that is the filament printer. Very easy to get into. The parts are relatively strong. They're never going to be as strong as a machine injected part, but there's actually some ways around that depending on how much work you want to do. You can actually get a considerable amount of extra strength out of a part like this. The biggest issue that you're going to run into as you print these flat layers one on top of the other is that they're not going to adhere to each other quite as well as you would like. They're going to stick together, but it's not going to be the same as a completely monolithic piece of plastic where everything is fully melted together. But one of the things that you can do is after you've printed something like this and you have the shape the way that you want it, and you have the sizes the way that you want it, and you have your focus just like perfectly dialed in there, which is easier done than said, you're able to take this shape and then you can either put it inside of a plaster of Paris mold by just putting plaster of Paris around it, or there's a guy on YouTube that has been doing a pretty good job of just packing the part directly into powdered salt, I guess. Yeah, and then putting it in the oven at much higher temperatures than this actual hot end can get to, and that anneals all the plastic together. All of those layers that are just barely stuck together turn into that monolithic annealed piece of plastic. So you get a solid chunk of plastic that is actually solid, and it is as strong as that material can possibly be without the difficulty that you have when the layers are separate. So I'm going to break one of these now on camera so you can kind of see the weaknesses. This has been printed oh, the focus. This has been printed this way. So it's actually very easy for me to take the layers and pop them apart because they're just not as strong in this configuration because it's been printed this way. And so in some ways it's pretty strong. On some axes it's pretty strong. It's stronger than on others. And so it shouldn't be that difficult Actually, I'm wrong. This first one I printed a different way. But it still is going to be fragile. It still is going to be easy to break this plastic, and you can hear it cracking along its weak points. So this plastic is always going to have its structural failings compared to something that is injection molded or that is injection molded out of a different kind of plastic. But if you print with ABS like this, technically that's the exact same material as Legos. And Legos are extremely strong when they are injection molded and they are a complete monolithic piece of plastic. And they're deadly. They're deadly if you step on them. So that's a very important thing to remember. That's why, again, I like my Air 15s to have a little task light on the bottom, lets me avoid Legos on the floor. The Legos are so deadly, I'd prefer to avoid the Legos, walk over where the landmines are instead. Much better. So as you are prototyping your products and you're printing things out and you're running into limitations with the material, occasionally there are ways around that. And there's various other things that you can do if you are trying to make a part that needs to be strengthened in a specific way, but it does need to have complex shapes to it. You print the complex shape out of plastic, but then you reinforce the parts that need the reinforcing with perhaps pieces of aluminum rail, or maybe a U-bolt, or maybe if you needed a threaded hole, you could set some brass threaded inserts directly into the plastic and melt those into place so that now that they're firmly attached to the plastic. There's a lot of ways that you can work around some of the limitations that you're going to run into with the $230 machine over here. Now over here, let's talk about the resin printer for a while. The resin printer works, it's a completely different way, but it's kind of similar in that the resin printer is, I'm going to unplug this laptop here, Charles. Hope that doesn't mess anything up any worse than it's already been messed up. The resin printer prints in layers, but instead of extruding liquid plastic, what it does is it has a little tank of a epoxy resin down in the bottom, which now that I've taken the lid off, you can smell it really good. It smells like brain cells dying. But it is, I don't really want to dip my finger in it, but I'm going to show you that it is liquid. This good, let me put it over there. This good liquid stuff right here. It's not actually going to, it's not actually going to be as strong a plastic as you can get from here, but there are different resins that you can use. There are different colors, they have different properties, and the way that it works is UV light comes up from a screen on the bottom and solidifies the shapes that you want, and they become a hard plastic, a semi-hard plastic, actually, I would say. And so one advantage that this machine has over this machine is that it is an incredibly finely detailed system. I'm not sure if you can tell, but when I hold up a 3D printed object that is printed on the filament printer, you can really easily see those steps. And when I hold up something that's been printed on the resin printer, you cannot see any of the layers. And you can make incredibly detailed things, like inside of this little rook chess piece, you can actually see that there are steps, but there's a spiral staircase inside. All of the detail is captured there. There's really tiny words on here. Just the amount of detail that you can get in these resin printers is incredible, even though sometimes it is, for some applications it's slower, for others it's faster, and there are different materials that have different material properties that may not be what you're looking for functional parts. So one of the things that we have done at T.REX is we will print functional prototypes over here very quickly using the strongest plastic that we can, and then we'll print those exact same files once we've gotten a few revisions in on this machine where the tolerances are very, very tight. The detail is extremely high. We can actually double check them as they interface with other parts of mechanical designs or other parts of things, and just really make sure that our design works from a really finely precise side of things after we've made sure that it also works from a functional side of things. So the Elegoo Mars, I think it is, as of today, $300 on Amazon. And one of the things that you will need to do with this printer is, as soon as this is done and your part is finished, you just pop it off and you're ready to go. With this thing, you get a part off. It is mostly hardened epoxy, but you need to clean it because it's covered with the unhardened epoxy, and then you need to harden it some more under some ultraviolet light, which if it's sunny outside, you can just put it outside. So there's a little bit more setup and cleanup involved on this side of things, and the strength just isn't really there. So I would say start with this and then figure out if you need this later on. So I was going to try to keep something of an eye on the comments, but they're going very, very quickly. They make very strong resins now. They do. The resins are getting stronger, and there's a whole bunch of different things that you can do with this printer. There are specialty resins that are rubbery. Now, there are filaments that you can print over here that are rubbery, but there are some resins over here that I want to play with. One of them is a wax-based resin because it will let you do something kind of interesting, which is lost wax casting. So what you can do is you could print a part like this, or anything out of something that is very similar to wax. It's an epoxy that has a lot of the same characteristics as wax. And then put that inside a plaster of Paris mold. Then melt the wax out. Then melt aluminum and pour it inside. We've actually been doing a little bit of aluminum smelting here at the shop, which is kind of fun. This bar of aluminum, I know it looks like silver, but it's not. It's purest sterling aluminum. Split top, butter top ingots of purest aluminum. We've been melting down some of the chips from our CNC machine and just experimenting with our crucible and our forge as we get ready for other casting projects, just making blocks of spare aluminum. So hopefully we'll actually get around to doing some lost wax casting or possibly some other casting of aluminum. And then, you know, once you have this kind of capability, once you have the ability to make plastic parts, test those, make finer quality parts, build molds around those, cast them in aluminum, it doesn't take a whole lot of tools to really clean up some of those cast parts and make them usable objects for certain applications. Not all, but for some of them. So that's a very interesting set of tools that we should be aware of. Now, there is a tendency in our, is it our community, or is it just kind of everywhere? There's a tendency on the internet for certain people to be incredibly optimistic about not just the future, but what they could actually do with this machine or that machine. And these machines are not going to topple giant corporations or traditional manufacturing capabilities. What they let you do, though, is work better with those traditional manufacturing technologies. So I have a friend, he's a young guy who has a 3D printer, and he wanted to develop a product. It was an adapter that went from one mechanical device to another mechanical device. He used Fusion 360 to build the object that he wanted cut out of steel, and he 3D printed a few revisions of that until he got it where he wanted it. And then he came to our shop, and because he already had the 3D model, he already had the tests, he already had revisions, the first try almost worked. The only reason that it took 2 tries is because we actually broke a bit, but that wasn't his fault. But the second try was a finished steel part that worked perfectly. It fit both of the mechanical devices that he was trying to connect, and he was not an engineer or a machinist, but because he was able to tinker and experiment and work out the bugs over here, he was able to walk into a machine shop with a machinist and just make it happen. So the opportunity to develop stuff with these and learn how to do stuff with these is tremendous. You're not going to make all of the mechanical devices that you need for future pursuit of happiness and liberty on one of these devices, but you will be able to teach yourself incredibly valuable skills, make a whole bunch of really useful stuff, but you'll also be able to use these sorts of things as the stepping stone to other manufacturing tools and technologies. So So yeah, that's a very important part of this whole conversation. Let me skim through questions really quickly. 3D printing is slow. 3D printing is fairly slow, but if you're like me, you generally try to get 4 or 5 hours of sleep a night. I believe that the 3D object that I was looking at earlier, this is a 1 or 2 hour print, I think, if I remember correctly. The object that I showed earlier that was named after Bob Menendez, a very distinguished legislator in the United States of America, that's probably a 4 or 5 hour print, and it's really easy to save that onto a micro SD card, stick it in here, start print, and once you've got your machine dialed in, I actually feel pretty comfortable letting it print overnight. And we have printed a number of 12, 13, 14 hour prints before. So yeah, there's ways around that. There's ways around it, even though you can't necessarily speed it up a whole lot. You can certainly be efficient in the way that you work. So yeah, the other thing that you can do is if you have need for a lot of prototypes very quickly, you can have more than one machine. It's $236 on Amazon right now, so it's not, it is, if you legitimately need to crank out a whole bunch of stuff, there are ways to do that. Someone points out 3D printing is slow compared to what? Yeah, I mean, it is not bad compared to certain other things. Now, I will say that getting our own Haas machine and cutting steel and aluminum is pretty amazing because especially when you're cutting aluminum, which is as far as CNC machines go, it's basically plastic. When you're cutting aluminum, you can go really fast. So 3D printing these parts is, I think, pretty slow compared to cutting aluminum on the machine, but it depends on what you're making. The other thing that's fascinating to me is there are a ton of machine shops in the United States that have amazing manufacturing capability, and in these machine shops you have machinists. So if you went to them and you had a napkin sketch of a part or a device that you wanted to make, they may not be able to help you bring that entirely to completion. But if you had a copy of Fusion 360 and you had a CNC machine, you could do a huge amount of work in developing that part and testing that part and visualizing that part and prototyping that part. And so then when you go and talk to the machinists at your local machine shop, you are able to give them all the files that they need, physical prototypes that they can look at to help them really figure out what it is that you're trying to accomplish. And then those machinists are going to be able to make that part perfectly. Way better than if you have a napkin sketch and you can't even really figure out how to articulate what it is that you're trying to create. So these machines have the capability to drastically increase the time from idea to proper manufacturing, even if these machines aren't proper manufacturing themselves. So yeah, there's a bunch of really interesting opportunities that I think these machines open up, even though in many ways these are kind of toy machines. And the thing that they are best at is it's kind of making toys. But if you are careful and if you are deliberate and if you are diligent, you can make toys that are prototypes for other things, and you can get those other things made properly. And you will have educated yourself considerably in the process. So that is very important. A bunch of folks asking about metal printing. There's a lot of development in the different technologies of metal printing right now. For sure. Now, the reason that I'm focused on these is because of how affordable they are and how easy they are to set up and how easy they are to learn. And I think that metal printing is going to get cheaper for sure, but it's also going to be, there is going to be a cost barrier, regardless of how cheap it gets. There's probably a limit to how safe and how cheap you can make a machine that sinters steel powder together. There's just some electrical requirements there that are hard to get around. Some of the cheapest 3D printing or metal 3D printing additive manufacturing techniques I've seen actually involve basically it's a 3-axis system very much like this, but on the end of it is I'll on the end of it is a metal feed, and it's basically welding material down into a blobby, rough shape of what you were actually trying to create. And then you take that blobby, rough shape over and you mill it down to the actual thing that you want to create. So that's going to be one of the most cost-effective ways to get into it. It's going to be like a mini CNC machine that has, I guess it would be TIG welding would be one of the most useful ways of doing it, a TIG welder on the side. But that's, you know, there's still a limit to how cheap that can possibly be. But some of the most fascinating metal CNC machines are capable of doing fantastic stuff. So there are a number of high-end 3D printed parts that are going into very high-end defense industry, firearms, and also missiles. So there's a theory, or there's a prediction that in the next few years, inside of the aerospace industry, about 70% of the parts of rockets and missiles are going to be 3D printed using very big, expensive 3D printers that are going to print titanium and Inconel and these other really exotic materials. And that is extremely cool. I'm really excited about that, but I'm also not expecting those machines to be in my price range or in my expertise range anytime soon. That's going to be something that is a little bit more difficult to do. And so use these as a stepping stone to learn the techniques, the theories, the coordinate systems, the CAD stuff as you move in that direction. But I really don't see a future where it is as easy to have a 3D printing machine inside your garage as it is to have a CNC machine inside your garage, cutting stuff out of aluminum and cutting stuff out of steel. That is very easy to do. And it's also relatively affordable if you know what you're doing and you're willing to tinker a little bit. And that's the sort of thing that these machines let you tinker ahead of time, figure out what it is that you actually want to accomplish, what it is that you're actually trying to create, experiment with some of the tools that you're going to need, etc., etc. So yeah. Print annealing. Going back to print annealing, you can heat up the oven. Well, you could just throw this into the oven, but it would just melt into a puddle. So what you really need to do is support this shape with a mold or with some sort of medium like powdered salt, where you can really pack it together and it's not going to allow this to dimensionally change shape while it melts. If you can do that, then you can anneal it and it stays in this exact shape. It all melts into a contiguous piece, and then you chip away the mold and you have just plastic left. Now this piece has some kind of complicated internal cutouts for mounting the different M-LOK hardware, and so you end up probably having a little bit of a tough time chipping all of that particular plaster of Paris out if you went with that mold. So yeah. Yeah, it's a fascinating thing. I have so enjoyed watching this technology develop, even though I feel like we're never going to actually get kind of this vision that a lot of libertarians have, which is everybody is able to get for a couple $100 a Star Trek replicator that just punches parts out regardless of what it is that you want and regardless of your actual ability to run the machine. It's not quite that easy. I don't see it ever being quite that easy, but I don't want to discourage people from getting into this because the skills are very easy to learn. And even though this machine takes tinkering and ABS is tricky to print and PETG is very tricky to store in Tennessee where the humidity is so high, these are all things that you can learn to work around. And it's never going to be a magical replicator, but it is going to be something that is highly useful for all sorts of things if you have all sorts of useful things in mind. So yeah, 100% infilled if you're annealing stuff. Yes, absolutely. Sand casting. Yeah, green sand casting is interesting. There's all kinds of amazing manufacturing and prototyping techniques that these things open up. And I don't even want to get into all of those because A, a lot of them I don't understand fully. B, I haven't tested them. There's plenty of YouTube folks who are better explainers of how to do this and better demonstrators of it that you should go and look up. So that is something that I would recommend that you guys do probably before you spend the $236 for this machine. But yeah, anybody can pick this up and learn it. It's very simple and straightforward. So Yeah, there's a whole bunch of really interesting developments that are happening with the resins and with the filaments that change things a little bit. So those are all good. And there's also just people that have interesting ideas. So there's a guy on YouTube whose name I forget because I forget most YouTubers' names, but he was using a resin printer to print forming blocks that he was putting into a hydraulic press and forming metal around these parts that he printed in here. These parts are fairly brittle, but he was using a resin that had, even though it didn't have impact strength, it had a great deal of compressive strength to it. It didn't have good tensile strength, but it had great compressive strength. And so he was using this hydraulic press to shape sheet metal around the forms that he was printing on his machine. So I'd never seen anyone do that before, but that opens up a whole world of possibilities. If you have a certain device or perhaps a certain firearm that has a stamped sheet metal receiver, this might be a way where you can begin to make, replicas of that so that you can sell them on Etsy, because that's what, I think that's what YouTube wants us to talk about. When we talk about 3D printing, I think we're supposed to stick strictly to Etsy marketplace products. Your Dark Souls figurines, your Warhammer figurines, stuff like that. This machine's great for that. And various other stuff. So again, my recommendation for you guys is to really consider this. And there's something else about this that makes me very excited, which is this is a great bit of decentralizing technology. Even though this is not the best way to make plastic parts, the best way to make plastic parts is injection molding. I would far rather there be thousands and thousands of people out in the world who are experimenting, developing their own stuff, and then learning how to do stuff with even not the best possible way of making stuff, but something that is accessible and something that is workable, something that gives them some restrictions that they have to overcome. I'm really excited about what it is that my kids are going to be able to do growing up with the expectation that you can learn how to do stuff and you can make stuff using the tools that you have lying around, but also that they're going to have tools like this lying around. So my recommendations are start learning Fusion 360. As much as I hate Autodesk, and as much as I hate Fusion 360, Confusion 360 as we call it here, it's free to start using it. There's a gazillion tutorials out there, and we are kind of using it for everything inside of the shop. So we're using it to build 3D models that we 3D print. We're using it to build 3D models that we cut on the Haas machine. We're using it to build holster molds now. We're using it to build the patterns that go to laser cutters when we need stuff laser cut, that go to the big Gerber knife cutters when we have fabric cut. Like, it is becoming the CAD package for kind of all the jobs. So definitely look into that. If you don't want to do that and you just want to do interesting meshes, there's a ton of other options. Blender is free. FreeCAD is interesting. I'm not sure if I'm totally recommending FreeCAD yet, but FreeCAD is an open source Fusion 360 alternative, but Fusion 360 is kind of great. It has the 2D tools, it has the 3D tools, it has mesh tools, it has CAM. It's very nice. So yeah, that's something that is, I would recommend that you guys, at the very least, start watching some Fusion 360 tutorials and getting a better idea of this sort of thing. And this isn't all about guns. I know that you think that because T.REX Arms is a gun channel and because I've been dancing around some of the things that you might possibly do with some of these printers, that what I am referring to is firearm manufacture. Yes, sometimes, but also all kinds of manufacture. And one of the things that is exciting to me about some of these technologies is the idea that this does decentralize a lot of things. It decentralizes defense if you make firearms. It decentralizes other stuff if you make other stuff. So one of the trends that we are seeing when we talk about ghost guns, it's not so much a firearm control policy. It is a push within the government to control certain types of information, to control certain types of tools, to control certain types of code, and that is highly problematic. And we're also seeing that drive, that direction, that desire in other places besides firearms. And we're seeing that in the corporate world as well. There are massive corporations like Apple and John Deere that do not want consumers to be able to repair or modify the products that they have purchased from them. So there is a movement called Right to Repair that there's a lot of misinformation about it, but generally speaking, that's something that I support. I think that if you buy a product, it is yours, and you should be able to mess with it, and you should be able to, you know, void the warranty without facing criminal charges, which is something that a lot of the direction that we're seeing in the legislature is kind of discouraging. But the fact that you can buy 3D printers, the fact that you can buy CNC machines, the fact that you can buy smelting equipment, the fact that you can buy tools is something that is very encouraging. And as you learn these skills and use them as a stepping stone to other things, you are decentralizing some of that power. You're decentralizing the manufacturing capability that really needs to be in the hands of the people for a lot of reasons. Partly because of freedom, liberty, and the pursuit of happiness, but also because the government is tremendously incompetent, and letting the government control really important economic engines like manufacturing is economic suicide, and then, you know, eventually other kinds of suicide. So you want to avoid that in your local economies as much as possible. So that's something that I would encourage you guys to really think about as you are considering some of this stuff, because the opportunities to decentralize manufacturing and spread around some of the skills of being able to invent and develop and problem solve in this area of creating tools that are necessary, that's a really important thing that we need to do right now. As the technology for making stuff gets cheaper, easier, more powerful, more effective, at the same time we are seeing we're seeing a trend to the government wanting to control more materials, more information, more instruction and speech. So that is something that we really want to push back against. And the good news is it's really, like we talked about earlier in the stream, it's really hard to stop people from making things that are really easy to make. And it's really hard to stop people from communicating ideas that are really important to communicate. Inventive, industrious, free-thinking Americans have always been able to work around this stuff. So actually, the easiest thing to do is to make sure there aren't any free-thinking, industrious Americans, which is something that, well, our public schools are kind of awesome at. So that's another thing that you should probably check out of as you look into more decentralized stuff. So yeah, keep learning some of these really interesting skills and be encouraged that it's really easy to get into this stuff and to make stuff. There is a maker community out there that there's kind of two branches of it. One is very, I'm not even sure what the right word is, infantile in some ways. I would say there's nothing wrong with starting out with toys when you begin. That's what my kids are going to start out doing. But there's a bunch of maker people who just want to make toys and stop there. But there's also a hacker community that is far more advanced and always wanting to push the envelope. And those guys tend to be a little bit more interested in freedom, which is one of those things that pushing the envelope generally moves you towards. And our community should probably be better friends with that community. So look up hackaday.com and look at some of the stuff that people are doing to build their own CNC machines, their own 3D printers, tinker with new materials, and develop very cool new electronics. So yeah, so those are a couple of things on your to-do list. Look into 3D printing. Don't buy into kind of the utopian makerspace. The future is going to be just Star Trek replicators in every home line, but definitely think about ways that it does improve and decentralize stuff. In almost every local community, you have some pretty capable manufacturing equipment already in your local machine shops. If you learn how to be a kind of an engineer, developing and working on this stuff and prototyping it locally, then you can, I'm sure, find ways to manufacture stuff locally. And again, the technology is getting so much better. The software is getting so much better. The capability to talk about and spread these ideas is getting so much better, even in the face of limitations and restrictions, that we just need to make the most of these opportunities, and not just use them for toys, not just use them for entertainment, but actually be thinking about what we can accomplish with them. So 3D printing is a fascinating thing. The amount of speed and agility that T.REX has squeezed out of these two machines, $300, $236, and about $50 worth of resin and filament, is extremely impressive. It is incredibly helpful to the way that we manufacture other stuff. We make clamps and tools on these machines that help us make Kydex holsters and help us make nylon stuff. So the opportunities to implement some of these things into your into whatever it is that you are doing, I think, is really helpful. So thank you so much for watching this stream. Again, I really appreciate all of you tuning in. I also appreciate everybody who subscribed to push us over that 1 million. That's a pretty big milestone, you guys. I know that YouTube won't actually recognize it because we're technically not a YouTube partner. We've been demonetized and we didn't jump through the right hoops, so they're not going to send us a gold YouTube play button. But we could print our own gold YouTube play button. We could actually melt some gold, although it's starting to sound really expensive. Maybe we'll melt some aluminum and we'll make a homemade aluminum play button to celebrate that. But actually, you know what I think is more likely? I think we're going to make a banned item instead. That's actually probably how we're going to celebrate the 1 million subscribers. But we won't post it on YouTube. But maybe we'll post it somewhere else. Somewhere else that you can find information about T.REX. Maybe on our website. Maybe on our newsletter that you could subscribe to. Maybe on our podcast, which has 50 episodes now. Maybe you can find some other information about some of this stuff, because you can certainly find some fascinating information about guys who are making ghost guns, terrifying, scary ghost blasters using this exact 3D printer right now, today, and doing some pretty solid research at the same time.
That person may or may not have been in the chat.
Oh, excellent. I'm sorry that I haven't paid really close attention to the chat. I'm doing the exact same thing that I always do on these streams, where I try to watch the chat, and all it does is distract me from my notes, and I try to read my notes, and all it does is distract me from the chat. So thank you so much, guys, for watching. We'll see you next week with a similarly well-prepared and similarly distracted topic. Have a great week.